So we're going to do the thunder and lightning in a grid that looks like this. We're going to do more of a vertical rectangle, and we're going to give it 2 columns, and the left side is going to have 3 rows, and the right side is just going to be open. And the left side we're going to label lightning, and the right side we're going to label thunder. Luke, what are we doing? If you need to borrow a pencil over there. All right. There's actually 7 types of lightning, but a bunch of them are variations of a main type. So I'm just going to do the 3 main types. We're going to have type 1. It's called intra-cloud, I-N-T-R-A. And for the A, I'm going to use ampersand, an @ sign. And you'll see why in a minute, because that's going to be our memory hook. So we're doing I-N-T-R ampersand, that's the @ sign, intra-cloud. And this is our memory hook. So this is at the same cloud. I actually made that too big. I'm going to erase that and make it smaller. Actually, I'm going to skip the word the. I'm just going to do at same cloud. And then we'll draw one. We learned yesterday that inside the mature thunderstorm, we have an updraft fighting a downdraft, and that creates friction, and that friction displaces electrons from atoms, and those electrons have a negative charge, and now they're free floating. So what happens inside of a cloud, and I'm going to simplify it, I'm going to put some negatives over here, and then underneath it, in parentheses, I'm going to put NEG for negative. And then over here, I'm going to put some pluses. And in parentheses, I'm going to put POS for positive. Yep. Hi. Which one? I got 2. Penny or Turner? Turner. All right. And so what happens, we're going to put a couple little factoids down here. The first factoid, we're going to define lightning. So lightning I'm going to blame that on my eye. You can't see. Lightning equals a discharge of electricity in the atmosphere and the second factoid we're going to put is that lightning follows the path of least resistance. Now, hopefully by now, we've learned that the polarity of charges in electricity acts like the plus and minus poles of a magnet. When you put two like poles of a magnet next to each other, what happens? They repel. What happens if you flip it around and put a positive and a negative next to each other? They attract. Same thing with electricity. So if you've got a negative and a positive area of charge, they're attracted to each other. And if they get close enough and the charges are strong enough, then the electrons will, we call it arc or bolt, to the positive. All right? They will travel in the path of least resistance. What does path of least resistance mean?
Future.
Why future?
Because it's
Path of least resistance. What's resistance?
pulling back. So it's like pulling back. Pulling.
Something. It's something. Yeah, it's something that is inhibiting something else. If you're resisting something, I'm trying to get you to do something and you're resisting me, you're trying not to do it. Well, lightning or electricity follows the path of least resistance. It's what a football play is designed to do. The running back is going to try to find the places where the defense isn't. That's the path of least resistance. That's why they don't always run in a straight line, because sometimes they're running and there's a dude here and I got to go this way, and then there's a dude there, so now I got to go that way, and I'm trying not to hit the other dudes. That's the path of least resistance. Well, that's what lightning is going to do. That's why the path usually isn't straight. It's crooked. And if the path of least resistance is inside the cloud, then the electricity is going to travel in the cloud. And you'll get lightning inside the cloud. That's not my best lightning. I've drawn better. And I'm on film. I'm very disappointed in myself. All right, 2. Inter, not tra, inter cloud. This is cloud to cloud lightning. So sometimes what happens, we're going to draw 2 clouds this time. And there's a buildup. Let's put some pluses here. There's positive right here. Let's put some minuses on this cloud. Negatives over here. Sometimes the path of least resistance is from one cloud to the next cloud. These clouds are really close to each other, and the path of least resistance is between the clouds. And then the type that you and I think of most of the time when we think of lightning is cloud to ground. So now you got a negative in the cloud. The ground is always positive. And now the path of least resistance is from the cloud to the ground. The cloud is close to the ground. The ground is a great big positive. Earth is one giant positive charge. So if you get a negative charge close enough to Earth, Earth is going to pull that arc down to the ground. Yes.
What about heat lightning?
This is heat lightning. I did a quotation mark and a parenthesis. I meant to do 2 quotation marks. This is heat lightning. I'm not sure it was named by a meteorologist. I think it's kind of like an old colloquial saying. I think farmers and probably agrarian type people would see this and thought it had something to do with heat. Maybe it was hot days that they would see this. I don't know. But anyway, this is, if you've heard the term heat lightning, it's usually referring to this type of lightning. Lightning happening in the same problem. Could be this. Could be this. Yeah. No. No. All right. Ready to talk about thunder? By the way, did you notice that that was a tree?
Yes.
I should have drawn a palm tree, but I'm trying to show you that I have multiple skills.
Yeah.
It's amazing.
Aiden was
All right. So we're gonna in our little talk about thunder, we're gonna refer to it for obvious reasons in a minute. We're gonna refer to it as clap of thunder. Have you ever heard anybody say, "Ooh, that was a loud clap of thunder"?
No.
Probably you guys don't say that as much as my generation would say that. But
I say that.
Oh.
We know.
if you all want to say it real fast, then you can say that you
Clap
say
of
it.
thunder.
Clap of
Clap
thunder.
of thunder.
All right, my turn. All right, what we're going to draw over here on the kind of the bottom half, we're going to start our lightning in about half of this area right here, and I'm going to go burn, 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 burn. And then moving up from here, I'm going to go dotted lines. For like the top half of the lightning. And what I'm trying to draw here is lightning doesn't stay in one place very long, right? It's there, and a millisecond later it's gone. Show me with your hands what heat does to air. What does heat do to air? Yes, if you went like this, then you're tracking. Heat makes air expand. All right? Is lightning hot?
Yes.
Yeah, it's hotter than the surface of the sun. It's hot. All right?
Wait, it is?
It is. It's not hotter than the core of the sun, but it's hotter than the surface of the sun. And so that heat makes air expand, and it expands violently. But a millisecond later, it's gone. What's that air going to do now?
Shrink again.
It's going to come back together. And apparently, air doesn't have very good brakes. It doesn't stop when it gets to where it was. It keeps on going, and it smacks into itself. And so all along a streak of thunder, or a bolt of thunder, or an arc, or lightning rather, all along the path of an arc or a bolt of lightning, air is rapidly and violently expanding and collapsing, and everywhere, right, look at my finger. Lightning starts here, expand, but now it's not here, it's gone. Collapse there, expand here, but now it's not there, it's here. Collapse there, expand here, but now it's not here, it's here. Collapse there and expand here. And so you're getting that boom, 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 boom. And it's very fast. That's why it sounds like a rolling clap. Right? So that's what's going on. So we're just going to take a heated part of the air and a cool part of the air. We're going to do this. We're going to label this part of the air right here. This is heated air. This is cooled air. Heated air violently expands. All right? Violent expansion. And once it's gone, then you've got this cool air left that's now going to contract. So this is violent compression. And right here where it's collapsing, this is your clap. Right? Ooh. So what causes thunder? Yeah, it's the heat from lightning causing air to violently expand, but because it doesn't stay there very long, just as fast as it expands, it comes crashing back into itself. And you wouldn't think that air could make noise hitting itself, but it makes a lot of noise. It's a lot of air. Yes? All right. We good?
Mm-hmm. Wait, no.
Questions? How are we going to sort out intra and inter? The at sign for intra. We're gonna make that A with the at sign. And remember that this is at the same cloud. All right. Can I erase now? All right. Now I'm going to go to tornadoes. And we're going to do this like we did thunderstorms. And we're going to do hurricanes the same way. Because there's 3 stages. So we're going to make our rectangle this way. Make 3 columns. And a second little row down here for our labels. Stage 1, stage 2, and stage 3. 3 stages of a tornado. About to blow your minds. You never knew this was going on above your head several times a month during the summer.
Even in Florida?
Even in Florida. All right. The first stage is called the supercell. The second stage is called horizontal rotation. And the third stage is called vertical rotation, aka funnel. Supercell, horizontal rotation, vertical rotation, aka funnel. We're making a funnel cloud in the last stage. Actually, we're making a funnel from a cloud. Technically. All right, supercell, what that is. A supercell is a very large thunderstorm. We are building a big old cumulonimbus cloud. We're not building your average, ordinary cumulonimbus cloud. We're making a big old one. Don't correct my English. I don't know if that's what you do for big old.
Isn't it big old though?
No, it's not old. Big old.
It's O-L-E.
Is it O-L-E?
Uh-huh.
I don't know. I think it's O-L with a little caret apostrophe thing.
Mississippi.
Is it O-L-E?
Yeah.
I think you might be right. Big old cumulonimbus cloud. All right.
Yeah, like Ole Miss.
Thunderstorms. You focused, remember? All right. Tornadoes are birthed from thunderstorms. But not just any thunderstorm. It's got to be a big old thunderstorm. All right? And we call these big old thunderstorms supercells. So that's the first stage. These are the ones, these start to rotate. We look at these with Doppler radar and we go, we're keeping an eye on that. The thing they're usually keeping an eye out on when they put out a tornado watch is a supercell. They've identified one. All right? All right. Here's what's going on inside these big old supercells. We learned that... Not us. How long do I have, though?
You have 8 minutes.
8 minutes. We can do this. All right.
Yeah.
All right. So we learned that there's updraft, fighting downdraft in these thunderstorms. And I want to remind you that this updraft is warm. And this downdraft, because of the altitude, is cold. And what you end up having is warm air getting replaced by cold air, getting pushed up as warm air, getting replaced by cold air. And what we're ending up with inside this very large cumulonimbus cloud is a horizontal column of rotating air. You never knew that was going on above your head. You just thought it was a great big old storm cloud. All right, so now you've got a horizontal column of rotating air. All right, we're going to split this one in half. And here, this is an imbalance of updraft. So we've got our horizontal column of rotating air. changing colors here for effect. And we've got an imbalance of updraft. We got a big old updraft on one end of this column, and on the other end, we just got a little bit of updraft. We got an imbalance of updraft. You see it? It's pushing harder on one end of this horizontal tube than the other. What's that going to do? Logic, people. Yeah, it's going to tilt that end that's getting the more push. It's going to tilt it up. And now, instead of a horizontal column of rotating air, we have a vertical column of rotating air. So I'm going to draw my columns like this. I'm going to draw 3 different columns to kind of show on this one, I'm just going to add my little cloud to it. So what's happening, now I'm going to change colors again so we can see this, is we've got this big imbalance, right? See what's happening? And this is your funnel. Who knew? Yes. Oh, you knew? Good job. What a knew. So we start out with these big old thunderstorms, supercells. Developing inside these supercells is a horizontal column of rotating air. It's that rising warm air fighting with that dropping cold air. And again, the bigger the difference in temperatures here, the stronger the rotation of that horizontal column of air is. And then if we get an imbalance on one end or the other, it doesn't always happen. There's usually always this going on inside those supercells. And if the circumstances just line up perfectly, and you get an imbalance for a long enough period of time to stand that thing up on its head, then you get a vertical column that drops down out of that cloud. Gravity will pull that thing down out of the cloud, and you got a funnel. You got a tornado. And we could talk about why gravity doesn't pull this down like a funnel cloud, because gravity is spread across a wider area. But when you flip that thing on its head, it grabs the bottom of it harder than the top of it, and that pulls it down out of the cloud. You guys did great. Thank you very much.
Say bye. Say bye. Bye.